dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Assalamu alaikum. Welcome back from trees. This is our Amano e-learning program is. So we shall continue our lesson. So you came across first lesson, so this is the second lesson, e-learning program. So we were in periodic table. So you came across definition of periodic table. Again, definition of periods. You came across definition of groups. Also, we came across how many groups we have in modern periodic table, how many periods we have in modern periodic table. We came across these areas. So the last slide was groups we divided as vertical columns of the periodic table. So keep going. So this was the previous lesson. So if we keep going, these are the 8 groups of our periodic table. Here we have missing elements. You see, first step we mentioned that this periodic table or modern periodic table based on atomic number. For example, start from this one. It has 1, say 2, next to that one 3, 4, 5. So this is based on 1 to negus. So if we start from this one, hydrogen, helium, lithium, beryllium, boron, carbon. So the number or atomic number increases from left to right, which means this kind of periodic table based on atomic number. There is another periodic table which is called classical periodic table. It was developed by Mendeleev. That periodic table is based on atomic mass, but our modern periodic table based on atomic number. So if you consider here missing elements. So what are missing elements from this periodic table? You see in this periodic table the symbols are replaced by atomic number. So we put the atomic number and missing where. So can we see some numbers from here? Can we see? If you consider this kind of periodic table, for example 22, 23, 28, if you read like this one, can you see some missing numbers? If you consider here, this is 56, this is 57, so you are expecting 58, but you don't have 58. What about here? 87, 88, 89, so we are expecting what? 90, and you have 104. So some missing, you see here, in here you have what? Some elements are missing from here. You see some elements are missing from here, some are missing from here. So those are called missing elements. You see how many columns? You see this is for example we can say here we can put here, okay. For example, this is period 1, this is period 2, say period 3, 4, period 5, period 6, period 7. So the other elements or the other rows or columns are okay, but in here you see some elements are missing. From where? From period what? Period 6 and 7. These two periods, some elements are missing from these two rows. So we can put here these two rows. Here are, you see, if you consider the other periodic table, there are here you have two main rows. Those two rows came from where? From here. In between 5, 7, 72, 8, 9, 104. So these are, we have here our modern periodic table, 2 rows. So these 2 rows are missing from here. These 2 rows are called lanthanides and actinides. So why are we calling lanthanides and actinides? From here, this is lanthanum and actinium. That's why we are calling lanthanides and actinides. So we want to take the names from the elements. So that's why we are calling lanthanides and actinides. So these are called missing elements. So why are we putting here? You see, in another way, our modern periodic table we can classify into blocks. You see, this group 1 and 2, this is group 1 and this is group 2. These two groups are called S block elements. You see, all transition metals around here are called D block elements. What about start from group 3 up to 8? These groups are called B block elements. You see, B block elements, these are called S block elements. Those missing elements, we remove it from here, are called F block elements, which means when we want to configure electrons of these elements, they should end up F. You see, all electrons in group 1 and group 1 and 2, they end up S. Transition metals ends up D. What about transition metals? They ends up B. So you should see this one in form 4. How to arrange these electrons into the shells. That's why we removed these two rows from there, from here. So these are called lanthanides and actinides are called missing elements, but they are not missing from whole periodic table. But they are not their position. They're supposed to be there. So what will happen if we put in here? The periodic table should become what? Very large. So it's better to put here. It's better to put under the other normal rows. So these are called lanthanides and actinides. Okay. If you consider here, this is the line. We already mentioned it here. This is the line again. So they are called lanthanides and actinides and are only shown on some periodic table. But most of the periodic table we put what? Under the normal rows. Okay, so keep going. Various families of the periodic table. You see some of the families are various. For example, when we want to do this periodic table, we want to focus two groups of the periodic table, two groups of metals, another two groups of non-metals. If you remember, we already mentioned it, this part is metals. What about this part? This part is non-metals. So these groups are metals, these groups are non-metals. For example, we want to mention, we want to explain, we want to do this one, alkali metals and alkaline earth metals. We want to do these groups. So these are metal groups. They are all metals. Group 1 and group 2 metals are metals. What about here? We want to do group 8, noble gases and halogens. These are non-metals. So we want to explain two groups from the metals and two groups from the non-metals. Why we say so? We want to compare the properties of metals and non-metals. Again, we want to compare. So if you know the properties of group 1 and group 2, you see these two groups, they behave in a similar way. Their reactions are not the same, but it's a similar. What about noble gases? We choose noble gases. Well, because of what? Noble gases, they are completely different from the other elements. Say both metals and non-metals. What about halogens? Halogens, they behave like non-metals. They always behave like other non-metals, like chalcogens, the group 6. So some properties of chalcogens and halogens are similar. So we want to do these 4 groups. We want to explain these 4 groups. Okay, so let us come to here. So these are called important elements. You see, where we saying so, these are important elements. We use these elements. For example, hydrogen, lithium, sodium, magnesium, potassium, calcium. Even our examples, we use this. These are group 1 elements. Hydrogen is outside the main group. We use iron. Even the real life, we use iron. Iron is most widely used in metal of all. You see, we use silver. Copper, zinc. We use all these metals, but the most usable, utilizable metal is iron. Here we have aluminium. This aluminium. We use again. It is the next to the iron. We use carbon, what we call graphite, sometimes diamond. We use silicon. We use nitrogen, phosphorus, oxygen, sulfur, say fluorine, chlorine, bromine, iodine, and helium. So these are the usable elements or utilizable elements in our society. That's why we are explaining now. So important members of the elements. So individual member of selected elements and their characteristics and their properties. Okay. So in summary, we want to use this. For example, metals, because our periodic table it contains some metals and some non-metals. You see, metal groups or metal groups, alkyl metals and alkaline metals, say transition metals. These are metals. These are metals. So they have similar properties. So what is that property? You see, these elements tend to give up electron to form cations, which means they lose electrons. Metals are losers. They lose electrons. They are losers to the other element. They give up electrons to the other atoms. What about the non-metals? What about the non-metals? If you consider here, what about the non-metals? Noble gases, halogens, chalcogens, which is group 6, these elements tend to accept electrons to form anions. So noble gases are always exception. Or because of what? They can't lose electrons and they can't accept electrons. They are inert, what we call unreactive gases. But non-metals, halogens and chalcogens, they accept electrons from the other atoms like metals. Then these two groups, say these metals and non-metals, they combine together. You see, some of the elements they lose electrons, others will accept electrons. Then they form what we call ionic compounds. Ionic compounds. So ionic compound is a compound containing metal and non-metal atoms. So metal from these groups and non-metal from these groups can form cobalt ionic compounds. But noble gases are exception. They can't lose or accept electrons. Even they can't share electrons. So when metals lose electrons, they form what we call cation, which means positive ion. What about non-metals? Non-metals, particularly halogens and oxygen group or chalcogens, they accept electrons from the other atoms. Then they form what we call anion. So positive ion and negative ion should form ionic compound, which is neutral. They cancel their charge. So these are the behavior of the electron transfer of metals and non-metals. Okay, we have groups of elements. You see, we already mentioned it there. We want to explain group 1 and group 2 as an example of metals. Again, we want to explain group O, which is completely different from the other groups, and group 7, which indicates some properties of non-metals. So here we have what? In general, groups of elements, whether they are group 1, group 2, or 7, elements in the same group have a similar chemical and physical properties. For example, all elements in group 1 have what? Similar both physical and chemical properties, which means they have a similar color, they have a similar melting point and boiling point, density, viscosity, color, taste. These are the physical properties. What are physical properties? What about the chemical properties? Which means they react in a similar way. For example, they can react with oxygen in a similar way. They can react with water in a similar way. They can react with halogens in a similar way. Even their structure is similar. So I can say all elements in the same group have a similar both physical and chemical properties. So that's number 1. Number 2, they have a same number of valence electrons. What does it mean? They have a same number of electrons in their outer shells. Valence shells means outer shells. For example, group 1 elements, they have what? 1 electron in their outer shell. Group 2, they have 2 electrons in their outer shell. Group 3, they have 3 electrons in their outer shells. Which means what? The outer shell electrons and the group number is the same. For example, group 7, they have 7 electrons in their outer shell. That's why we are calling group 7 electrons. So the number of electrons in their outer shell is the same as the group number. They will form same kinds of ions. For example, if group 1, they lose 1 electron, so they are monopositive. Group 2, bipositive, they lose 2. Group 3, they lose 3. What about halogens, or what we call noble gases? Halogens, rather noble gases. Halogens, they accept 1. What about chalcogens? They accept 2, which means they have 6 electrons. In order to become a full outer shell, they accept 2 electrons from the other atoms. Here we have the this this row, first row, is lithium, sodium, potassium. So this is group 1, which means they have 1 electron in their outer shell. Group 2, 2 electrons in their outer shell. Group 7, 7 electrons in their outer shells. So if you consider this, they have 1 electron in their outer shell. So these belongs to group 1, 2 belongs to group 2, 7 belongs to group 7. So the number of outer shell electrons and group number is the same. It's the same. What about, can I put an element which have 5 electrons in its outer shell as a group 7? No, it's supposed to be group 5. So my student I want to summarize this lesson here. So we shall continue. Okay, thanks a lot.